All right, heads up, I'm sitting outside because I just had to get outside. So hopefully the audio works out okay. You might hear some birds chirping in the background. We're going to start with an anti-set of just reviewing how to take some derivatives using some different rules that we've covered. So you should try to do these by yourself. You should also be finding f prime x right here as well. And then I will go over how to do them. Okay, so this first one is just a basic power rule. I'll go over here. So I'm going to multiply by 5 out front times x to the 4 power. Just apply that power rule. All right, second one is going to be a chain rule. So I have to do the derivative of the outside function. Derivative of sine is cosine. And then I leave the inside function alone. And then I'm going to multiply by the derivative of the inside function, which is 2x. And I'm going to shift this over one sec. Okay, so now multiply by the derivative of the inside function, which is 2x. Okay, and then this last one's going to be a product rule, which this is the one we've worked with the least amount so far, so this might have been tough. So we start by doing the derivative of the first function in the product, which is e to the x. And then we multiply by the derivative of the second function in the product, which is, we leave the second function alone, so e to the x times cosine x. Okay, plus we leave the first function alone, and obviously this looks the same because the derivative of e to the x is just e to the x, so that term doesn't change really. And then now we have to multiply by the derivative of cosine x, the second function in the product. And the derivative of cosine x is negative sine x. So what I'm going to do to make this a negative sine x is I'm just going to change the positive from the product rule to a minus, because that's what's going to happen when we multiply by negative sine x. So then that's your final derivative, e to the x cosine x minus e to the x sine x. Okay, so now we're going to review some power rule, and I think power rule is the thing that we're all pretty good at, except for we haven't done a lot recently where they're like fractional exponents, right? So we're going to rewrite x, square root x as x to the 1/2, right? We're going to rewrite cube root x as x to the 1/3. We're going to write 1 over x to the 5th as x to the negative 5th. And then, this is kind of progressing in terms of difficulty. You know, we do fractional exponents, we do negative exponents, and then the most difficult would be a negative fractional exponent. So we can rewrite 1 over the 4th root of x is 1 over x to the 1/4, which we can then write as x to the negative 1/4. So now that we have these in a better format, we can now apply our power rule. So we get f prime x equals 1/2 is going to jump out front times x to the, what's 1/2 minus 1? That's negative 1/2. Okay, so then it's now convention to get rid of these negative exponents, or not get rid of them, but just rewrite them so they're not written as a negative exponent. And then this ends up being 1 over 2 root x. And again, this is just one you're going to probably end up memorizing as you go into your calculus courses. It's one that's going to come up a lot. The derivative of root x is 1 over 2 root x. Okay, let's do x to the 1/3. So we're going to have our 1/3 jump out front. So we get f prime x equals 1/3 times x to the, what's 1/3 minus 1? 1/3 minus 3/3 is negative 2/3. So it's going to be 1/3 x to the negative 2/3, which will then be 1 over 3 times x to the positive 2/3, which we then should rewrite as 1 over 3 times the cube root of x squared. We should be able to take a fractional exponent and put it back in radical form. And go. You got to be able to go both ways, basically, when it comes to that conversion. Okay, so our final derivative is 1/3 times the cube root of x squared. Okay, moving on. Okay, let's do x to the negative 5th. So this one's going to be a little bit easier. We're going to multiply by the negative 5 out front. And then what's negative 5 minus 1? It's going to be negative 6. So our final answer here is going to be negative 5 over x to the 6th power for our f prime x. And finally, we'll do the 1 over 4th root of x. So this is going to be the trickiest one we've done. So this is going to be negative 1/4 out front times x to the what is negative 1/4 minus 1? What is negative 1/4 minus 4/4? That's negative 5/4. Okay, so then we can rewrite that now as negative 1 over 4 times x to the positive 5/4, which we can then rewrite as negative 1 over 4 times the 4th root of x to the 5th power. Okay, f prime 2, g of 2, f of 2, g prime 2. So we'll find f prime 2 first. So let's erase here and then go to the row that we're working with. That's the row at x equals 2. Okay, so what is f prime 2? That's equal to 5. What is g of 2? That's equal to 3 plus. What is f of 2? That's also equal to 3. And then what is g prime 2? That's equal to negative 5. So then we get 15 plus negative 15, which is just going to be 0. Cool. All right, moving on. More product rule. So they can mix it up even more and make one of the functions defined by a function that we know, and the other function defined by this table. And we still are defining h of x as the product of the two functions, so we still need to write h prime x equals f prime g plus f g prime. Okay, so then if we want to find h prime 2, we need to plug in 2, obviously. So we do h prime 2 equals f prime 2 g of 2 plus f of 2 g prime 2. Now the thing is, f and f prime are defined by the function f of x equals x squared, and then g is defined by the table. So what we should do is we should come up here and we should say f prime x equals 2x by the power rule. So f of 2 is going to be 2 squared because the function's x squared, and that's equal to 4. And then f prime 2 is going to be 2 times 2, which just also happens to be 4. So f prime 2 is 4, f of 2 is 4. Okay? Now what is g of 2? We have to go to our table. G of 2 is equal to negative 1. So we have 4 times negative 1 plus, what is g prime 2? G prime 2 is equal to negative 2. So 4 times negative 2. So this is negative 4 plus negative 8, which is going to be equal to negative 12. Okay, you can try to do it for 5 now, h prime 5. Okay, so we have to do f prime 5 g of 5 plus f of 5 g prime 5. So let's find f prime and f of 5 first. F of 5 is 5 squared because the function's x squared, and that's 25. F prime 5 is going to be 2 times 5, which is 10. Okay, so we can plug those in. F prime 5 is 10, and then f of 5 is 25. Okay, now what is g of 5? We have to pull that from the table. G of 5 equals 6. So we have 10 times 6 plus 25 times g prime 5. G prime 5 is negative 5. So we do 25 times negative 5. Okay, 10 times 6 is 60 plus 25 times negative 5. It may seem like this is a hard one to do in your head, but it's actually easy to multiply by 25 because 25 times 4 is 100. So 25 times 5 is just going to be 125. So this is plus negative 125. So then that should simplify to negative 65. Sweet. I'm going to try to get this lesson done all in one video as opposed to switching it or splitting it into two. Okay, so we're just going to do basic chain review real quick. So if I have e to the sine x, I need to start by doing the derivative of the outside function. So sine of x is the inside function because it's getting plugged into e to the x. So we're going to do the derivative of e first, which is just e, and then leave the inside alone. And then multiply by the derivative of that inside function now, which is cosine x. Okay, so for this next one, f prime, okay, x cubed is plugged into cosine x, so x cubed is the inside function. We do the derivative of the outside function first. Derivative of cosine x is negative sine, and then leave the inside alone, and then now multiply by the derivative of the inside, which is 3x squared. Okay, so that's our basic chain rule review, and now we're going to make it harder by working with tables. So we have m equals f of g of x, and we want to find m prime 1. So what we have to do is define m prime first. M prime x equals, well, it's the derivative of the outside function f, leave the inside function alone, then multiply by the derivative of the inside. So then think back to how we did these other table examples. What do we have to do? Well, we have to define m prime 1. That's what we're trying to find. Replace all your x's with 1s. F prime g of 1 times g prime 1. So what's getting plugged into f prime is g of 1. So we got to determine what g of 1 is first. So g of 1 is equal to 3. So we're going to do f prime 3 times, let's just figure out what g prime 1 is here. So g prime 1 is equal to negative 3. So we're multiplying by negative 3 out here. Now we need to figure out what f prime 3 is. So f prime 3 is equal to 4. So we have 4 times negative 3, which is ultimately going to be negative 12. So same principle, we're applying the chain rule, but we're just trying to use a table of values instead to get to our final answer. Okay, so let's do another one. So again, making this a little bit trickier, we have to define h prime, and we have a combination of table functions and normal functions. So we have h prime x equals, f of x is plugged into root x, right? So we need to do the derivative of root x first, which I'm not going to show the work behind because we did it earlier. It's 1 over 2 root, leave the inside alone. Okay, and then we're going to multiply then by the derivative of the inside function, which is f prime x. If you copied this table, I changed the output for f of 3 to 9, so just to make it a perfect square. Okay, so now let's do h prime 3. So we do h prime 3 is going to be equal to 1 over 2 square root f of 3 times f prime 3. Okay, so the first thing we have to figure out is f of 3, and f of 3 is equal to 9, as I changed it to make it a perfect square. So this is 9, and then what's f prime 3? Looks like it's equal to 4. Okay, so we have that this equals 1 over 2 root 9 times 4. Okay, root 9 is equal to 3. So we have 1 over 2 times 3 times 4, which is just going to be 4 over 6. 2 times 3 is 6, and then on the numerator we're going to have 4, and then obviously this simplifies to 2/3. So h prime 3 is equal to 2/3. We had to do our chain rule. We had to do the derivative of the outside function, 1 over 2 root, leave f alone, and then multiply by the derivative of f, all with 3 plugged in. I know I've generally been talking a little bit fast here, and I'm hoping that you've been rewinding when needed, and I should stop talking now because I have less time to do this example. Again, it's going to be a little bit quick, but just rewind as much as you need, okay? So this is a product and a chain because within our product, both of these functions have a function inside of them, okay? This is a function times a function, and each of those functions has a different function plugged in. So we need to do the derivative of the first function in the product, which is e to the x squared. That is e to the x squared times the derivative of the inside function, which is 2x. And I'm going to put that out front because it's going to look a little bit neater. Okay, leave the second function alone. Plus, leave the first function, e to the x squared, alone, and then multiply by the derivative of the second function. So now we have to do the derivative of sine 5x. Okay, so we have to do the derivative of sine 5x. So we get the derivative of sine is cosine, leave the inside function alone, and then we're going to multiply by the derivative of the inside function, which is just 5. Again, most of the times if you see this answer as like a multiple choice question, the 5 will probably actually come out front and not be at the end. So, but we're just multiplying by 5 because that's the derivative of 5x. So here is your final derivative where we've applied the product rule, and then for each of the derivatives we had to take within the product rule, we also had a nice chain rule.